Okay, so for this problem, we need to choose an a and a b value that created a special right that could be the legs of a special right triangle. I got a and b. My a and b were both 15. I plugged in the equation z equals a minus bi. The equation looked like this: z equals 15 minus 15i. So this is the beginning complex number that we're going to be using. To begin, we must determine the z to the power of 7. And the way that we can do this, so initially we need to get into this form right here. So we need to determine what the r is, and the way that we can determine the r is by doing take the square of the two coefficients of the complex numbers and then add them together, and then from there we can take the square root of the value to determine that the r value becomes 15 radical 2. We can plug that into the equation, so that's what we have so far. And then since we took 15 radical 2 out of this original equation, we need to manipulate this a little bit. So we know that if we take 15 radical 2 out of this equation right here, this value is going to become radical 2 over 2, and this one will become negative radical 2 over 2i. And then from there, we know that radical 2 over 2 is part of the 45, 45, 90 degree triangle. So we need to find where the triangle would be would have a cosine that is positive and the sine that is negative, and essentially this would be in the fourth quadrant. And therefore, we can swap this equation out with this one right here. And this one right here, because we know that taking the cosine of 315 is equivalent to root 2 over 2, and same thing for taking the sine, because the legs are both I'm blanked out for a second. And then from there, I'm trying to think. Sorry, I'm blanking out. Okay, so from there we can deal with the power of 7 by taking the modulus right here, the 15 radical 2, to the power of 7, and from there we get 2.1 times 10 to the 8th. And then with the argument, the angles in the argument, we can simply multiply by 7 to get that 2,205 degrees for both of these angles, and that can be simplified to radical 2 over 2 and radical 2 over 2 I. And the final equation will look like z to the 7th is equal to 2.1 times 10 to the 8th, parentheses, radical 2 over 2 plus radical 2 over 2i. And then from there, we must determine the fifth roots of z. To determine the modulus of the roots, you just take the fifth roots of 15 radical 2. Here, sorry, I move that up a little bit. And you get 1.84. You're just taking the root of the modulus. And then from here, you can divide the original argument by 5 to get 63. And then the reason why we divide it by 5 is because we're looking for 5 roots. And then 63 was the beginning root, and since we know that there's going to be 5 roots in total, I took 360 degrees divided by 5 to get 72 degrees. And with that 72 degrees, I added to the 63 degrees for each of the roots following. And essentially, these are all the 5 roots. There's the first one, second one, third one, fourth one, and the fifth one.